is a problem 8 from my manual. That's it. We have a frame structure. We have a one concentrated load. We have a copper or moment going forward to the coordinator. And this is the A and this is the B. What the reaction at the B? So again, this one is still coming from the Woody Mail here. It's not a friction problem, it's joint anything like this. Free body diagram. This is the pin, this is the roller. So pin means we have to have this and we have to have that. We don't know which way it's gonna go. I'm gonna just put that all the way. Roller, we said we should have only one. So A is label them, reaction at A. And reaction at the B, this is the X, reaction at the B in What would you say about this? What is this? Could you tell me right away? What is it? How much is it? Huh?
Zero.
Do we all see that zero?
No.
Because summation of x supposed to be equal to zero, it's nothing. We all see that. We want to find the alpha of A, that's the question. So I'm going to take a moment about the B then. I'm going to take a moment about the B. It'll be minus 10 times of 10, going this way, negative. What should I do about this copper? What do I do about this? It's already copper moment. So all we have to do is it's going clockwise and negative 40. So copper can be any place. It doesn't affect the problem. You see it? And plus R sub A that times 20 is equal to 0. So there will be minus 10 times 10 minus 40, just moment, and plus R sub A that times 20 is equal to 0. That's all there is to it. So answer is Also, weight is 7 kilonewton. I'm still playing with the chapter 2. So we are getting the truss problems, the structural problem. We have a 3-story building, and wind pressure is whatever, and it is acting this way. Pin and roller. All we want is this one. That's all we want, each. This is somewhat like a cantilever problem that we discussed earlier. Or structure is just on one side, act like a cantilever. So instead of rushing to get the reactions here and there, maybe we don't skip that part. So we should use the method of sections. Method of sections. How do we cut it? I can cut through this way. That gives 1, 2, 3 unknowns. I can cut through this way, 1, 2, 3. Again, that's a 2 unknowns, that method. How about the cutting like this? And instead of keeping bottom, I'm going to just keep upper part. I don't have to worry about the reaction business. unknown, this is unknown. We want to find the EG. So please look at the other two numbers where it's going into. And good place to take a moment is that D. Would you say D? And this two is going into that. I would take a moment about D being going in advance and right away. Moment equation would be this times 8, 30 times 16 plus EG that times 50 is equal to 0. We can see right away it's going to be a negative compression number. So best way to do is moment about the D is equal to 0. 30 times 8, 30 times 16 plus EG that times 15 is equal to 0. So EG is a negative 48. And negative shows that this is a compression number. Suppose this question is force in EG, not this one, but this one. We have three equations to play with. Summation x0, y0, moment 0. Why not say summation of x must be equal to 0? How does this sound? If x component of this one, I don't have to worry about these two. Just that's it. So to answer that, summation of x must be equal to 0. Let me dg slope. This is the 8. This is the 15. We have to figure out the other side, and that's 17. So x component has to be 15 over 17, and plus 30 plus 30 plus 30 is equal to 0. You can see right away dg is equal to negative something. Negative 1. Again, negative shows that it should be compression method. so much. We are pushing this way. And the question is pushing to the maximum distance h. Without the tipping is impending, so you can not only move this way, but also you can tip. The tipping is impending. Start with tip. It's a friction problem. Here is a normal force. If I were to push this way, frictional force will oppose that, which is mu times n. So we can say summation in a force y must be equal to 0. So from this right away, n has to be 1,000 Newton. Summation in a force, the x must be equal to 0. Mu times n, 0.25 times n minus p is equal to 0. So p has to be 250. So we know that this one is going to be 250. But if you overturn, they will overturn with respect to the point A. So we have to take a moment about the A. So next one is momentum about the A must be equal to 0. Well, then this times that minus this times that is equal to 6. 1,000 times half of that, which is 5 minus 250. That times h is equal to 0. And here, moving like h to be 4.
Right on. Thank you. How many pages? Three. Okay.
Professor, why did you only have one force for the 1,000? Why didn't you use the normal and the weight? Why did you just use the normal or just the weight?
Why did I,
Yes, for your moment about A,
yes,
why is it 1,000 times 0.5 over 2 and the 250 instead
this
of that
times
twice?
that.
Then why aren't you using the normal force, which I would assume?
Why did I use this?
Yes.
Well, these are, this is the, it shows the actions, what's happening. This is a reaction to it, so we shouldn't worry about all this. This is what's happening. We have a box, someone is pushing. We have a box, someone is pushing. So force we have to worry about is the weight and this force. What's happening and friction is resisting force.
So basically, once that action happens, that normal force is negligible? Or like doesn't happen because it's not, okay, never mind, I get it. Never mind.
Let's talk a little bit later, I
Yeah,
don't
I
quite
got it.
hear what you're saying.
Basically, because once it starts,
I guess your question is, why not include this and this, is what you're saying?
yes, yeah, and it's because
Yes,
once it
these
moves.
are the reactions that, you know, so this is what's happening to the body. What we have is this force and that force.
Yeah.
Just like if I were to push this one, blackboard is pushing me with that, you know,
Yeah.
kind of the same kind of thing.
I got it.
Okay. Let's go over this one very quickly. Problem one. I went over this one day one, so I'm not gonna repeat it, right? I'm not gonna repeat it. That's, the reaction was square root of 0.83 square plus 6.94 square is equal to 6.98. So A was, so let's please go back to the note we did in the day one. Okay. Problem two, exactly the same problem that I just did this morning. So I don't want to repeat. So problem, let's see, your notes. I went over that one this morning, okay? So A is the correct image. Three. Is that I have 400 newtons, and this is a point O. Distance from here to that is 150 millimeters. Replace this one by coupling force at O. I add 400. I subtract with the 400. So this times that is same as 400 times 150 is like a copper. Or 0.115, so that much is a 60 Newton meter. So what I have is this one I have is a force and the copper. I replace this one into force and the copper system. I add it, I subtract it, so I haven't changed anything. This and that makes a copper. So I replace this one into one force and one copper.
That's simple.
And we go force this way. The three boys have done this end. The slope of this one is a 3, 4, 5. This one is a perpendicular to that. So slope has to be, I have to switch it. So 3 is is a vertical and then horizontal, and 4 is a vertical and the 5. Do you see it? It's coming exactly like this. Vertical 4, horizontal is a 4 now. Horizontal is a 4, 3, and this 4. I will just change it because it's a 90 degrees. So this is a reaction at A, reaction at the B. The question is, what's the reaction at A? Why not this, the X and Y component? So this is the A, that times 3/5. This one is 4/5. So I can say summation in Y must be equal to 0. It's the equilibrium problem. See? So R sub A 4/5 of minus 120 is equal to 0. So from that R sub A is 450. D is correct. We have two unknowns, we have two equations right now. So it's coming from equilibrium. Number 5. Reaction at the B is free body diagram, or we will just take a moment about A to get a B out of it. As we said before, we chop this one, and in the middle there will be 1.2 times the 4 one throws from here